Okay, so this will be a tutorial about how to make an AI for an enemy in a platformer game, 2D platformer game. So let's first look at the example here. So we have this guy that can move around from the previous examples, and we have the enemy below that has two behaviors. He has the walking behavior, he walks and then stops for a little bit. And then if the player is in front of it, it shoots a projectile, and that projectile breaks into pieces on contact. So before we can look at the scripts, because we have three scripts, one for the enemy, one for the projectile, and one for these pieces that are spawned when the projectile collides. So let's look at the objects that we need first. We need the enemy. And also we need two positions because we want to spawn that projectile in a different position depending on the rotation of the sprite, so the flip of the sprite. So we have a left spawn and a right spawn. Then we need a prefab for the projectile. It's just a sprite render with a rigid body that's kinematic, so that means it can only be moved by script. And it has a script that will spawn those pieces on collision. So that's what this script here does. And then we have the pieces here. We have two pieces, different pieces. It's just a sprite render with a collider and the rigid body. And we have a script that will fade the transparency of these and then destroy it after some time. So let's start with the enemy script. I call it trunk because that's the name of this guy. So the idea is basically we spawn before we get into the code. The idea is we raycast every frame from the enemy towards the direction in which he's moving to detect the player. And if there is a player, then we enable the attack coroutine, the attack behavior, and if there is no player, that we just do the running behavior. So you see here we have this function which we use to raycast every frame towards the direction in which is moving, the enemy is moving. We have a function spawn projectile, and this will spawn the projectile and give it velocity. And we use this. We make this function public because we want to use it as an event on the attack animation of the enemy. Okay. Then we have the attack coroutine, that's the attack behavior, the run coroutine, the running behavior. And we have on trigger enter, we have some invisible colliders that will change the direction of this enemy when it reaches the end of the platform. So let's go to the code. Okay. So we have a move speed. We have the components that we need: the rigid body, animator, and sprite renderer. We have the transform, two transforms for the. This is where we spawn the projectile. So you spawn either to the left or the right, depending on the flip of the enemy. We have move direction. This is to set the velocity of the rigid body. We have two coroutine variables to save the coroutine. So we have one for the run behavior and one for the attack behavior, because we want to be able to stop this coroutine to switch from one to the other. We have the prefab of the projectile, and we have a projectile speed. And then we have the physics layer of the player, because when we raycast, we only want to target the player layer, physics layer. So in the start function, we get our components here. By default, the direction is left. We start moving, so we set the velocity to move direction times move speed. We enable the running animation, and then we start the run coroutine. So by default, when we start the scene, the enemy will be in the run coroutine, so the run behavior. And then here in update, we raycast from the enemy towards the direction in which it's moving. So let's look at the function. We raycast here, so you see the position of the enemy, move direction, so the direction in which is moving. That ray will be 100 length, and then at the end here, that's the physics layer. So the player, we will only target the player with this. So then we check if we collided with something, so the player, we stop the running coroutine here and we enable the attack coroutine. And if there is no player, then we stop the attack coroutine and start the run coroutine. So we switch between these two depending if there is a if the player is in front of the enemy or not. So that's what this does. We have the spawn projectile function. This will spawn the projectile and then give it some speed. So first of all, we have to decide if we spawn it to the left or the right. So we check if the move direction is bigger than 0. And in that case, we change the spawn to the right. And if it's not, by default, it's to the left. So then we spawn that projectile at that position that we decided. So here we spawn the projectile and save it in a variable. Then we get the two things that we need from that object, which are the sprite render and the rigid body. Because now we want to flip here. Here we flip the sprite of the projectile depending on the direction in which it's moving. And also we enable collider because on this projectile we have two colliders here. If I go to the projectile, we have one for if it's moving towards the left direction, if it's moving towards left, and one if it's moving towards right. So depending on that, we enable that specific collider. And then we move that projectile. So we set the linear velocity of the rigid body to move direction times move speed. So again, this happens as an event on the animation, the attack animation of the enemy. So let's look at the behaviors. We have the attack coroutine here. So the first thing we do is we stop movement. So velocity is vector 3, 0, but this is a mistake now that I'm looking at it. This should be vector 2, 0, my bad. Vector 2, 0. So the idea is we attack and then we wait some time and attack again. And this loops forever because we stop it by script. So we have a counter here that counts the time difference between frames. So in other words, it counts the time in seconds. So when we reach when it's time to attack here, so when the counter is bigger than the attack speed, we reset the counter, and then we attack by enabling the attack animation, because remember that the spawn projectile function happens as an event at the end of this animation. And then we wait 1 second and repeat this while. That's the attack coroutine. Run coroutine here, the first thing that we do is we enable movement. So we said that the velocity is move direction times move speed. We enable the animation, the run animation. And then this loop here, what it does is after a couple of seconds, we stop moving. We wait some time and then we go back to running. That's what this does here. So we have a counter for that. So when we reach the limit, we stop and wait for some time. Go to idle and we stop movement. We wait some time and then we go back to running. So this will basically what it does. It creates a pause between movement. So this is the script of the enemy, the trunk. Now the projectile here. We have those pieces. It's an array of pieces. In this case, we just have two types of pieces that will drop on collision. And then we want when those pieces spawn, we want to rotate them and move them in a random direction. So we have a minimum and maximum torque. That's the rotational force that will apply on spawn. And then we have the minimum velocity and maximum velocity. This will create a random velocity between these two to apply the force to those pieces. So on trigger enter, so collision without physics, we do that. We spawn those pieces and give them rotational force and velocity. So first of all, we create a random number of pieces between 2 and 4 in this case, because if you say random range 2 and 5, 5 is exclusive, so it's from 2 to 4. And we spawn a piece from 0 to the number of pieces that we created. And we want to spawn a random one from that array. So we create a random index here from 0 to the length of that array. We spawn it and save the rigid body. We create now, wait, what is this? Yes, now we want a 50-50% chance to rotate it towards the right or the left. So we create a number between 0 and 2. And we have this torque multiplier. So this will represent the direction of the rotation. And by default, it's 1. And then if that random number is bigger than 1, which will be 50% of the time, we make that multiplier -1. And then we add that we add the rotational force here. So we add that torque multiplier, which represents the direction of the rotation, times a random force that will be between that minimum torque and maximum torque. And then we create a random move direction here, and then we apply we add force to that piece to move in that direction. And after that, after we spawned all the pieces, we destroy this projectile because we don't want to keep it in the scene. And we have the same code here for collision enter. So that way, this will happen either on physics-based collision or collisions without physics. So that's the projectile. We have the piece that spawns when the projectile collides. In this case, we need the sprite renderer because we want to fade the transparency. So we have a fade duration, how long this fade should last, and then we wait some time before fade, so that way the pieces can fall and touch the ground, interact with the platform before we fade the transparency and destroy it. So in the start function, we get the sprite render, and then we start that. We have a coroutine for fading here. So like I said, we wait some time between fading, and then we fade it here over time. So you see, we update the color and change just the transparency here. This will fade that from 1, so completely visible, to 0, which is completely invisible. And after that, we destroy the piece, so we don't keep it in the scene. Okay, so again, I will explain this one more time. So the idea is we have two behaviors. We have a attack coroutine and a running coroutine, and we switch between these with this function here that will raycast in front of the enemy to detect the player. So if the player is in front of it, we use the attack coroutine. If there is no player, we go back to the running coroutine. So that will be everything for this example. Thank you very much for watching.